Okay, now, before I continue, okay, I want one last sidebar.
Oh. Goodbye work.
Just like we don't notice.
What do you guys remember about drag?
Derivative of acceleration.
Nope. What do you remember about drag from the lab?
Air resistance.
Okay, it's air resistance. Okay? There were two models that were introduced to you in the lab. The first model was BV, which is what we've been playing around with in the problem. And the second model was CV squared. Okay? That's a much less common model, but that's what you need in order to get the linear line that you were supposed to get in the lab. Okay?
That's what made sense.
So we're playing around with BV. That's fine. So drag is the force. Drag is the force. This is the acceleration. Okay? So just keep in mind that when you have a falling object, you have drag pushing up, gravity pulling down. So this forces are equal to the force of drag up, gravity down, and that's equal to the net force. And based on what we know from the problem, they're modeling this as MBV, so the mass times the acceleration, minus mg equal to ma. Mass cancels. So that's where, and they just flipped. They flipped BV and G. For some reason, they made G positive. Makes it look nicer, I guess, when you don't have a leading G, or leading negative. So they came up with this. So that's where this is all coming from. Okay? Now keeping this in mind and what you're familiar with, they just jumped from this to this when they made the question.
But it says BV minus G.
Right. That's what they have in the question.
Because if you
Because
treat
they
it,
just flipped the direction.
so why would you get negative B then? Negative A.
If A would become negative if you solved for anything when you did this, because it's still a falling object. So they just made it negative or made it positive.
How did this
Because FNet is technically negative
negative G?
in all scenarios.
I guess.
Okay.
Just
Now,
leave
keeping
those
this
there,
in
'cause
mind.
This would be negative, and they don't want negative.
Because this is how you guys are familiar with. This is how you're familiar with drag. What does a velocity versus time graph look like on when you graph out the motion of an object? Straight. It's not a straight line.
A line. Well,
You're right. It is a line, but it's a curved line.
not.
Can you describe the motion of a falling object with air resistance if it had a lot of space to fall?
So
Oh, it's like
like
a
a
exponential.
Or no, it'll
Oh,
be
the
parabola.
Is it
Parabola.
exponential?
No, with
It'll-
air resistance.
Just the speed.
So caps out.
Just describe the
Air
speed of the
resistance is
object.
minimal when
So
you
it'll
start, and then it
increase,
speeds
speed
up.
will
and then
increase,
Speed will increase.
and then once the drag is equal to the weight, it'll just become a constant.
Right. So it would look like this, right?
Yeah.
That's what you described. It's an increasing speed, and then eventually becoming constant. What does this graph look like?
Rad x.
Log.
What kind of log?
Natural.
Not really like a, it's not, yeah, it's the natural exponent. Okay? Keeping this in mind,
to kill myself.
and knowing that this is the behavior of a drag function, and an object falling due to air resistance, or with air resistance, when we finish this, we should get a natural exponent. Okay? And that makes sense because we already have natural logs popping up. So this is tying the math and the physics together. You have that background knowledge that you should have a natural log in there. No?
Oh no. Matt?
Okay. So when you add two ln functions or subtract two ln functions together,
Divide.
you divide what's on the inside. So minus 1 over b. B minus bb over g
Hear all my comments. Let's keep it.
equal to t.
That's what I like.
Simplify.
To the front page now, I see. Knowledge of the school.
I like knowledge in school. Yeah, elementary school was fun. No, I don't.
Okay, and I still have to isolate v by itself. So now, in order to get rid of the natural log,
E to the something.
e, so I do e to both sides.
Mr. Bergstrom?
Yeah.
Does that say -1 over b ln, or is it just -1 b ln?
The ln is on the outside, it's not in the fraction.
Yeah, it's on the outside.
Huh? Oh.
Oh.
Anytime I freaking change. Do you?
Do you?
The ln
Do
is.
you? I don't think she knows.
Now, question. What happens when you plug in t equals 0?
A lot of stuff happens.
It equals 1 on the inside. 1 minus 1 is?
0.
That checks out. What happens if t is infinity?
Oh, I love how
It gets infinitely negative.
It gets infinitely small. It goes towards 0
Oh, that's right.
because it's a negative bt.
Right.
So this goes towards 0. So then
Makes
you
that
have the
almost
equation
1.
g over b. Which, if you look at your original equation up here, I'll go back in a second. If a equals 0, v is equal to g over b. So we found the function for v.
Could you scroll up just a little bit? Doesn't want to be done. Or like back down, just like so I can see like the first part of your work.
How's everyone doing?
Doing terribly in school.
So what defines it as an integral problem?
Because you take the derivative of this whole thing.
What keyword do you see as it says?
What defines
This is 0.
what defines this as an integral problem for me is that we started off with acceleration and it's asking for velocity. Because you know the relationship between acceleration and velocity is an integral. Okay? It's just that it's a little bit trickier because what you are trying to find is also in the function given. That's why you end up with the natural log. Okay? Now, you would be able to do similar things with sine and cosine, and that's just simply memorizing or looking at what's on the back of your formula. You know that when you take the derivative of sine, you get cosine. When you take the derivative of cosine, you get negative sine. That is also fair game. But not much different. Kevin.
Do you think there'd be a way to do this if we just looked at the multiple choice options and then like kind of like plug
Sure,
in?
if you had a multiple choice test on Thursday and Friday.
Well, I mean, because this was a multiple choice question, right?
Yeah.
And so like.
And this is the problem that I've never taught this before. I've never taught it directly before. I've always taught it before you guys take your final. So this is something that students would not get the first time that they saw it, even with 5 options for multiple choice. I would say my running percentage on the practice test for this particular question is probably somewhere around 5 to 10%. All right. So yeah.
Okay, so how do you get this? So why is it so if you take the derivative? You see that this is equal to the derivative of the velocity?
This dv over dt means you're taking the derivative
So
of the
G
velocity
over
with respect to
G
the
is 1.
derivative of t.
Which is equal to acceleration, which is why it's equal to that,
I
right?
split it.
Yes.
I
So
split
then,
that.
how does it get from here to here?
Bergstrom, is that the only problem?
No, he takes the
I
antiderivative.
can do one more.
He takes the integral. He takes the integral of this. Yeah. That's what we're trying to do.
Oh, so he takes the integral of g minus bv.
He's dv over g minus b equals dt. He's just flipping these two.
So basically, multiply this times dt and divide this by. He wants to isolate the variable down just to dt. That's what he did.
Okay. Oh, so he put
So
that
multiply
here.
times dt, so it moves over here, and divides by g minus bv, which moves it back over here.
Just solve for dt.
So this becomes dv over g minus bv is equal
Yeah, no.
to
If you solve for dt, you get this, right?
Yeah.
Oh, so okay. So he just said that dt is equal to this.
Yeah.
And you solve for the integral of
yeah of those.
dt.
Yeah, of dt.
In the interval of 0 to 0.
Big T is.
Ooh, I got you.
Let's go. One instance of time. Okay, so here would be another function that you will see later, but I do want you guys to get familiar with this as well. Okay, just because we're practicing different integrals today. So you have 3 sine 2 pi small t, just like we've always done, and then this is big T. That does not stand for tension right now. That is standing for the period, so a specific given amount of time. What I want you to do is I want you to give me a general function of v using the functions on the back of your formula sheet.
General function.
Oh, dude. Yeah.
Wait, so is big T a constant?
Big T is a constant, 2 is a constant, pi is a constant,
3 is a constant.
3 is a constant.
T squared. T.
I got the answer.
Wait, which one's it?
Ooh, Tedley.
This one is easier, I promise.
So what'd you do?
I don't.
Oh, is this one? Oh, okay. Because you just We never solved the last problem.
That sucks. Right? You
We
just
just
solved for
did
B.
v equals. We just got v equals.
I think
That's it. That's the
it's
answer.
the same possible expression for B.